2.4 Day 9 Notes. Talking about transformations, specifically horizontal and vertical shifts. So let's jump right into the first example here. We're going to have 4 examples on these notes. I'm going to make some axes. I'm going to go up to 4 here, 4, then 3, then 2. So I'm going to make some axes. I'm going to plot 4 points here. So negative 2, 0, 0, negative 2, and then 4, 3. So plot those 3 points on your axes, and then I'm going to draw the graph through them. So this is going to be our graph for f of x. I don't have an equation for it. All I have is a graph. And I just want you to recall, when we talk about these points today, so for points on a graph, you can call them x, y, or you know that y is interchangeable with f of x. So you could also call it x comma f of x. So part A. If this is f of x, can you graph f of x minus 3? So the question is, instead of f of x, if you have a minus 3 in there with the x inside the function, what does that do to the graph? So if you remember back from transformations, if there's a minus 3 inside with the x, that actually shifts the graph right 3. So it moves everything to the right 3 units. Okay, so in terms of the points, we can find the exact points that we need to put down. And we're going to drag it to the right 3. So basically we just add 3 to each x value if we're going to shift this direction right 3. So for negative 2 comma 0, 3 comma negative 2, and 4 comma 3, we're just going to add 3 to each one of those x values. So for the first point, add 3 to the x value, second point, third point. So our new coordinates be 1 comma 0, 3 negative 2, and 7 comma 3. So we can do it algebraically here, or we can also just drag the graph and move it. So if I put those 3 points down, I shift the graph 3 units this way. So I take it, I drag it 3 units that direction. So in purple there, that's my f of x minus 3. So I have a minus 3 with the x, so I shifted it right 3. It's my purple graph. Let's look at example 1, part B. So I'm just going to get this graph up here again. Same graph. You should already have this one written and drawn. So here's f of x. What if I want to graph f of x plus 1 minus 2? So notice there's a plus 1 with the x, inside with the x. There's a minus 2 outside. So what does that do? So the minus 1 actually moves the graph left 1, or the plus 1 I mean, moves the graph left 1. And the minus 2 on the outside shifts the graph down 2. So we can subtract 1 from the x values and 2 from the y values. We're also just going to drag this graph left 1 and down 2. So our new points, first point, second point, third point, our new points will look like this. So let's go ahead and graph that, shift this graph left 1 and down 2. So let's grab those points, move them left 1 and down 2. So I took the graph left 1 down 2. This is what I should get. So I want to notice, I tried to draw it as the same, but just to be clear. So when I shift left, right, up, down, the size, the shape, and the orientation don't change for the graph. They're the same. So the size, shape, and orientation of the graph stays the same. Just because I'm sliding it up, down, left, right, none of this stuff would change. So for example 2, let's say the graph g of x, the graph of g of x contains the point 10, negative 16. This is all I'm going to give you. The graph of g of x contains the point 10, negative 16. That's all you need to know. So what point must be on the graph of, I'll give you a couple scenarios here. So all you know right now is that g of x, some graph, some function that contains the point 10, negative 16. So what would be on the graph of g of x minus 2? What point do you know for sure would be on that graph? Okay, well, x minus 2, since there's a minus 2 inside with the x, that shifts the graph right 2. So what would happen if you were to shift this original point right 2 units? Well, you'd essentially just be adding 2 to the x value. So if you add 2 to that x value, we're really at 12 comma negative 16. We know for sure that point would be on the graph of g of x minus 2. And then for part B, what about for the graph of g of x plus 1 minus 4? What point do you know for sure would be on that graph if this one is on g of x? Okay, so what happens with these two transformations here? So the plus 1, that moves the graph left 1. So essentially you would just subtract 1 from the x value. And then down 4, right? Because the minus 4, that shifts the graph down 4. So we're just going to subtract 4 from the y value. So what point do you know has to be on this new transformed graph? If you started with 10, negative 16, then transformed it, well, subtract 1 from the x, subtract 4 from the y. We're at 9 comma negative 20. So in general, let's talk about the rule for these things. Let's give a formula. For any function g of x, so y equals g of x, or any function like that, g of x plus k, where this plus k happens outside the function, what happens? What does that do to the graph? So you have g of x, and you put plus k on the end by itself. The k's out there. It's not inside the function. It's outside the function. What does that do? Well, in general, that's just going to shift the graph up or down k units. So if you have a number outside, it's just going to shift it up or down, whatever this value is. And then what about if you have a number on the inside? So g of x minus h. So you have like an h inside with the function. So the other case, if it's inside the function, and there's lots of different kinds of functions. There's like x squared, there's x cubed, there's a square root of x, there's lots of different kinds of functions. So if it's inside there with the x, inside the function, that shifts it left or right. So it shifts the graph left, right, h units. Remember, this one's a little bit backwards. That's why there's a negative in here, so it's minus h. So if it's plus a value, that shifts it to the left, and if it's minus a value, that shifts it to the right. We actually just saw that in the first two examples. So that's our general rule, our general formula for how graphs shift left, right, or up, down. Okay, so example 3. I'm going to do another little graph here. So I'm going to put points here at negative 3, comma 0, and then 3, negative 2. I'm just going to make a nice sketch. I feel like Bob Ross painting. If you don't know who that is, Google it. I'm going to make a nice little sketch from negative 3 to 3 on the x-axis. And this is going to be my function g of x. So negative 3 comma 0 for that point, and then 3 comma negative 2 for this point, and there's g of x. So that's what we're going to start with for example 3. And then what's the domain of g of x? Well, I already said that actually. The x values, it goes from negative 3 to 3 on the x-axis, and those are both included because it is closed at those 2 points. So now I want to ask you, what is the domain of g of x plus 1? So what would the domain of that be? And maybe you can already figure it out. Maybe in your mind you can visualize it, or you know what to do algebraically, you know how to add or subtract the numbers. So we know that the x plus 1, that shifts the graph left 1. So it takes this graph moves it left 1 unit. So what would the new domain be? Well, essentially we're just subtracting 1 from the x values. So if I can graph this in purple here, this would be my g of x plus 1. I just took the same graph and I shifted it left 1 unit. So that's g of x plus 1. And now you can just kind of observe what the domain would be. So it looks like now it's extending out to -4 and goes to +2 on the x-axis. So -4 to 2 would be the domain for the new graph, g of x plus 1. So these are the types of problems you run into. If I give you g of x, here's the graph, you know the domain. What would the domain be for a transformed graph like g of x plus 1? Alright, example 4, our last example here. Actually, I think there's 5. I take that back. I think there's 5 examples. The last one's a word problem. Okay, so x, f of x. We're going to make a little table here. X's go from -2 to 2, count by ones. And then f of x, they're a little bit scattered. -3, 4, 2, -1, and 0. So let's make that table to start out with. I'm going to ask you some questions about it. And the questions are actually, it's going to be really simple math. It's just we're going to get used to the kind of notation again. So I want you to evaluate a couple things. Part A, what's f of 2? So that means when you plug in 2 for x, what's the output? Well, this table is trying to communicate to you a 2 for the x. The output would be just 0. So f of 2, we can say that's 0 for sure. Then part B, what's f of -2 minus 3? What's f of -2 minus 3? So we really need to evaluate this first. What's f of -2? So can we evaluate this first? So when you plug in -2 for x, you get -3. So if that value is -3, like we'll plug in -3 for that. -3 minus 3. So the math's actually really simple. You just have to know what to do and in what order. So f of -2, that's -3, then subtract 3, so we're at -6. Part C, what's f of 1 minus f of -1? So again, you have to know what to do in what order. So you can give me an answer for f of 1, and you can give me an answer for f of -1. And let's start there, because then once we get those two pieces, then we'll be able to give the final answer. So f of 1, you plug in 1, you get -1 out. F of -1, when you plug in -1, your answer would be 4. So really, it's just -1 minus 4. So our final answer here, -5. Alright, part D. What's f of 73 minus 75? So these types of problems are meant to see if you know what order to do these in. There's no 73 and 75 on this table, but that doesn't matter. Order of operations would say you need to evaluate this number first. So this is really asking what's f of -2, because what's 73 minus 75? That's really just what's f of -2. Well, we can get that pretty easy. Plug in -2, the answer would be -3. Then the last one here, part E. F of x equals 4. So when you see a problem like this, they already give you what the output is. They tell you it's 4. They really want to know what's the x value that you would plug in to get an output of 4. So go up here to the table. We got an output of 4 right here. So the x value that corresponds to that would be -1. So our answer for that is just x equals a -1. So again, the math for these, pretty simple. It just comes down to, do you know what order to do them in, and how to evaluate each piece correctly. Alright, one more example here. It's a bonus example for fun, of course. Example 5. It's a word problem. So, T of D, T parentheses and the lowercase d, T of D gives the average temperature in degrees of Roselle. So this function gives the average temperature of Roselle on the dth day. So you plug in whatever day it is, the dth day of last year. Okay, so d equals 1 would be the January 1st, and so on and so forth. So that's our setting. We have a function, you plug in the day, and this gives you the average temperature for Roselle on whatever that day was last year. So we just need to interpret a couple things. This is really key for us. This is like our new thing this year, how to interpret, how to explain the scenario in context using words. So part A, what's T of 6 mean? So T of D gives the average temperature for that day. So what's T of 6? Okay, well, one thing to keep in mind. D is the day, the output, T of D, that's the actual temperature. So this would really mean like the temperature in Roselle on the 6th day of the year. So we can say it like this. The average temp on the 6th day, or you could just say January 6th. Part B. What's T of D plus 16? Okay, well, T of D is the average temperature. That's the output. That's going to give us a temperature, and then we're going to add 16 to it. So the output, the average temperature on the D day, whatever that is, and then add 16 to it. So 16 degrees more than the average temp on the dth day. So whatever day that is, doesn't matter. The average temperature on the dth day plus 16. So that's 16 degrees more than the average temp on the dth day. Then part C, this is our last one here. T of D plus 365. Okay, so now we're adding 365 inside this function. And that's where we input our days. So keep that in mind. Inside this function, that's where we input our days. So we're basically adding days. So this is like the dth day plus 365, aka a year later. So that's the average temperature a year after day D, or whatever that is, dth day. So the average temp 365 days later, or a year later than day D, or you could say the dth day. So that's how you interpret and understand what's going on with function notation and explain the math behind it using words from the problem in terms of what's going on with the problem. Alright, that's all for these notes. I'll see you in class.